let's talk about one-sided limit. This is an example of a piecewise defined function. This is called Heaviside function, h. It's defined to be 0 when t is less than 0. So when t is less than 0, h of t equals 0. So will be like this. Now because this is strictly less than 0, so this should be an open gap right here. H of t is equal to 1 when t is greater than or equal to 0. So when t is greater than or equal to 0, it's this horizontal ray right here. And because this one has an equal sign, so this should be a solid dot right here. So this function can be used to describe an electric current that is switched on at time t equal to 0. So before this time, it is off. So function value will be 0. But once you switch that on, then the current will be 1. So you have the current right here. Okay. So this function, when t approaching 0 from the left side, you see this minus sign here, indicating that t is approaching 0 from the left side. And when you put a plus sign here, that means t approaching 0 from the right side. So when t approaching 0 from the left side, remember along the graph, what happened to h of t? Well, the function value is always equal to 0 up to this point, right? So the function value is approaching to 0. If t approaching 0 from the left side, the function value is approaching to 0 right here. So the left-hand limit here, we say the left-hand limit of this function is equal to 0. Now what about if t approaching 0 from the right side? So when t approaching 0 from the right side, remember you have to go along the curve. So the function always take on the function value 1 on this side. So when t approaching 0 from the right side, the function is going to approach to 1. So this limit here is equal to 1. And we call this the right-hand limit right here. So this is the right-hand limit. And this one over here is the left-hand limit. The left-hand limit does not equal to the right-hand limit here. So we'll say that this limit here does not exist, DNE. Now, when you see t approaching 0, this is actually approaching 0 from two sides. So this is actually a two-sided limit. When the left-hand limit does not equal the right-hand limit, then this two-sided limit does not exist. So this two-sided limit is equal to a real number L, even only if the left-hand limit and right-hand limit are both exist and go to this number L right here. Okay, so take a look at this example right here. Okay, this is a graph of a function that g, which is given. That's a graph. When trying to find this one, the first one here is the left-hand limit of this function at 2. So 2 is right here. So x approaching 2 from the left side, we have to go along the curve. The function value is getting closer and closer to this number, 3. So this left-hand limit of the function at 2 is equal to 3. The second one, what about the right-hand limit at 2? So we have to go on the right side of this 2, but we have to go along the curve. So what happened to the function? The function value is getting closer and closer to this number, which is 1. So that's equal to 1. So right-hand limit equal to 1. Now what about this two-sided limit? So this two-sided limit over here, because the left-hand limit and the right-hand limit, they don't agree. So the two-sided limit does not exist. Okay, when they're different, then this limit here, this two-sided limit here does not exist. Okay, D. What about F5? Let's take a look at the left-hand limit. Left-hand limit is what? 2. What about on the right side? Right-hand limit is when you go along the curve approaching 5 from the right side, the function value is getting closer and closer to 2. So both the left-hand limit and right-hand limit are equal to 2. So both of them equal to 2. Now because the left-hand limit and right-hand limit are the same, they equal to the same number. So we conclude that this two-sided limit is equal to the same number, which is 2. Even though that g of phi does not equal to 2. So the function value is not equal to 2. In fact, it's equal to maybe 1.2.